Hey everyone, welcome. We are live during period one, Hrs Algebra 2. We're solving rational inequalities. Just so you know, if you want to be on this, you can keep on talking, but right now we are live. So if you have any questions throughout, please be sure to ask. Otherwise, if you want to wait until the end, you can. Today, what we're going to mainly focus on is solving rational inequalities, and then some domain restrictions. But you'll see those as we go whenever we do these solving. First thing that we'll want to do is we'll bring all terms to one side to combine with an LCD if needed. Simplify the numerators. Find key numbers, zeros from numerators and undefined values from denominators. And then use test values within each interval to solve the inequalities. Write the final answer in interval notation. So I already actually have this first one kind of worked out for you because I wanted to show you right off the bat what we're getting into and just kind of explain, because I feel like explanation is sometimes the best. And you to actually see the steps instead of me doing them at the same time. So the first example that we have here is 4x over x minus 3 is greater than or equal to 6. And I'm just kind of going to zoom in here to show you what goes on. So the very first step you want to do is get everything over to one side. Set everything equal to 0. From there, you want to find a common denominator. You want to make it so it's all one fraction. So 4x over x minus 3 minus 6. You want to multiply that by x minus 3 on top and bottom. And that's how we end up with one fraction of 4x minus 6 times x minus 3. I think, too, in terms of video, this makes it a little bit nicer for you. So once we've found a common denominator, we want to distribute that negative 6. So we'll end up with the 4x minus 6x plus 18 over x minus 3. And then combine our like terms so we get our simplified negative 2x plus 18 over x minus 3 is greater than or equal to 0. There's a really nice reason at the end, by the way, that as to why we set it equal to 0 or greater than to 0 or less than to 0. I'll get to there in a minute. So once we get that simplified, here's what happens. I'm going to take out and factor out my numerator as best I can. In this case, I factored out a negative 2 to make it x minus 9. That's going to help us whenever we find out what we're putting on our number line. If you remember way back, we did graphing quadratic inequalities, and we wrote a number line out, and we factored everything, and then we put our solutions of our factors on the line, and then we did the little does it fit in these specific categories. You do something very, very similar here. So I am going to erase this because I want to show you why this occurs. So all of your factors that you have, numerator and denominator, 3 and 9, those are the ones that are going to be there. What you want to do is, like we did before, pick numbers in each specific category, any number that's in between. So like any number that would be less than 3, any number that would be between 3 and 9, any number that's going to be greater than 9. And you want to plug them into your original equation to see if they work. If they hold true to the inequality, then that whole entire section of your graph will hold true for that inequality. If they don't, then it won't, and that's not going to be part of our solution. So down here, I plugged in 2, 5, and 10. And I plugged it into this top part here that I already had factored. And I want to show you it's not necessarily because it's because it's set equal to 0, it's not about the specific number you get, but whether or not your answer is positive or negative based on your inequality. So if I plug in 2, the first part of my inequality here, I'm going to circle in red, is already negative. So that means that answer is negative. 2 minus 9 is still a negative, and 2 minus 3 is still a negative. That gives us a negative answer, which cannot be greater than or equal to 0. So that part of our graph does not work for our solution. This is so you don't have to use all the numbers in order to solve. If you look at 5, okay, if I plug 5 into my equation, again, that first part, that negative 2 is negative. 5 minus 9 is negative. That'll create negative 4 technically. And then 5 minus 3 is positive. That creates a positive answer. Positive answer would be greater than or equal to 0. So that would be part of my solution. And lastly, 10. X is equal to 10. If I plug that in, that first part, that negative 2, that stays. That's negative. 10 minus 9 is positive. And then 10 minus 3 is also positive. So that would not work because that gives me a negative solution. And anytime you have a negative, it's not going to be greater than 0. Does that make sense? You can do it if you want to. Like, you can plug the numbers in and get a specific number. You can plug in 10 and get negative 2 times 1 over 7. It's going to give you the same result. It's going to give you a negative number, which can't be greater than or equal to 0 in this case. So now, how to write your solution, okay? Remember, we talked about interval notation and then domain restriction. In the previous type that we did, we didn't have a denominator. So everything was based off of our greater than or less than signs. In this situation, we want to base it off of our greater than, less than, or equal to signs, but we also want to note that if we have a problem with something in our denominator, we cannot have that be equal to 0. So for example, our solution here is 3 to 9. Because there's an equal sign, technically we would usually bracket both of those. However, because the 3 is in our denominator, that means that it cannot equal 0. Therefore, we're going to have a parenthesis around the 3. Essentially, anything in your denominator, you'll have a parenthesis around. And as long as you have an equal sign within your equation, then it'll also have the bracket as well. Questions at all? That's literally like it. That's the big focus. So I'm going to stop the video. Okay. Those of you out in video land, we'll see you next time.